Welcome all to this new video where we'll try to see how to write a program in Vivado and also burn that on an FPGA Basys 3 board, which is a basic board for all beginners. I will also see the constraint files and how to configure all the buttons, how to configure the LEDs. That all will be discussed in this video very precisely. So let's begin with double clicking on this Vivado 2016.2 is the version that I'm using. So you will see a window. This is the window that appears up, and if you have already created a project you can go for open design. If not, then you can create a new design. So let's begin with creating a new project. We click on this, so it will help us to create a new project through a new Vivado project wizard. So we'll click on next. You have a project name. Let's name it as test underscore dump, because what we are trying to do here ideally is we're trying to dump the code into an FPGA board, which is a base 3 board, which is a very basic version of FPGAs available. It has so many input output pins, I would say input pins and LEDs available through which we can see the output. So this cost me around, say, roughly around 20,000 odd rupees to ship it to my location. 20,000 plus, I think approximately 27. Anyways, the cost is not important, but its functionality is important. So I'll write as test underscore dump, and I'm going to design an AND gate. I cannot keep the keyword AND. I'll have to use AND underscore gate, say 2. Let's keep a random name. So following that, we will click on next. Then since this is an RTL project, so we again click next, and here we can add a source if we have already created, but we'll do nothing, but we'll keep it to VHDL, and this one also to VHDL, and we'll click on next, and we'll not add any IPs. Again click next. We'll not add any constraints as of now, so let's click on next again. So this is the important part where we have to select the target board or the target part. We'll try to search here the base 3 board. If it does not come here, we'll see the part. So base 3 board is not displayed by default, so what we will do is that we have Z board, Zybo boards all available over here, but in this version of the Vivado it's not available, so that's not a problem. Let's click on parts. We have already noted the part number of a base 3, that which FPGA part is inside this base 3 board. It is XE7A35T CPG 236-1. So this part is available. We'll double click on this, and the new project is configured for this part. As you can see, it is visible over here. So we'll click on finish. So our design has been created. Now in this case, in order to write our first program, we'll click on add sources. We are going to add or create a design source. Let's ensure that this option is checked. We'll click on next, and if you already have some design, let's either do it using that design, or if you want to make the new one, let's click on this button, add. So we are here with three options: add directories, or create files. So since we're going to create new files, VHDL files, so we'll click on create new file. File type is VHDL, and we are going to create an AND gate. So let's write the AND underscore gate underscore test. So it will remain in the local project, and let's click on OK. So by this, our VHDL file is being created. So we'll click on finish. Now we will have another prompt which will ask us that you have to define the IO ports. So since an AND gate, will make a basic AND gate with input A, it is of input direction, and another will be input B. This will be again input, and third is C. We'll mark this as output. So this has to be marked over here. So how many as many number of inputs and outputs can be declared over here, whether they are bus, whether they are single bit, they have to be declared over here. This will be for the convenience of a student who wants to learn this. Otherwise this can be written later on also. So we're done with this. This will result in creation of a basic VHDL behavioral program, which is named as and underscore gate underscore test over here. Now if we double click on this, we will have the program which we have to use for further dumping. But in this AND gate, what comes because of the already selected option is the entity that is written over there, and we behavioral is to be written. So we know the expression for an AND gate is. So this is how an what line we have added is that C is assigned as A and B. So this is how we write C output is assigned as, this is the assignment operator, is assigned as A and B. Our job is done. The rest of the things are generated by the program itself because of the inputs that we gave earlier. So we don't have to do anything. We just have to click on run synthesis. It will check for errors. It will do all of the things that are required for this case. We will not run simulation as of now because we know this is a very simple program. So let's not go to that part. Let's focus on running a particular program. So we can directly go for run implementation. There is no netlist file available. It says you have to first synthesize. So let's synthesize it first. Okay. We have to save this as well, and it will. The synthesis process is in progress. You can see synthesizing design, this one, and also you can see this small little circle over here. Now since it's complete and it is implementing the design, this is another part. Now please be aware that in order to finally dump this file on a device, you need to provide the constraint file. A constraint file is a file which tells us about so many details of the design, and more importantly it tells us about how a particular input is mapped to a particular pin or a button on the board, how a particular output of the program is mapped to a particular LED on the board. As of now, we don't have any constraint file attached to it. So it means that we will have to add a constraint file. Now, how do we get that constraint file? Uh, we'll search the term as base 3 FPGA master constraint file from GitHub or any other location. Once you do that, you will get one of the resources available. You can directly click on this. So in that you will find this file on the right extreme. So this is known as the master SDC file, which has information of all the ports, all the pins. You can just click over here, Control A, Control C, copy this file directly, and you will have to paste this file over there. Now, so design has been implemented. We will not open the implemented design as of now because we have to add the constraint file, so we'll cancel it. Now here on, we'll click on this. Now right click on this constraint file and add sources, because we are adding a constraint file, which is very important. So add or create constraints is option to be checked, and now click on next. Now here we will click on create file, since we have not created any files, so we can name it as bay underscore test, okay, underscore const constraint file. So okay, so we have a file available over here which is an xdc. Please remember the extension .xdc is the extension of this constraint file. So we'll click on finish. So we have this file available over here, which is the constraint file. In order to now view the contents of this file, we'll double click on this. So we have bay underscore test. Now this is empty as of now. What we'll do is that the content which I had copied from this GitHub as the master xdc file, so we'll just simply paste it over here. So Control V, all the parameters are over here. But you can see that all of these are basically in uncommented form. Now, in order to uncomment any particular function, we'll just remove this percentage sign and sorry, this hash sign. So, for example, the first thing that I need to be worried about is what IO standards and which pin we are going to use. Now, this is the most important part. Please be focused. If I see my board, if I see my base 3 board, suppose we are using these switches over here, these two switches, which is like switch number. Let's see what the switch number is. So your switch number 1 and 2 are your W16 and V16. So that means we'll have to configure W16 and V16 as the two switches which will work as input A and B, and we will use this LED, that is LD0, which is configured to U16 as our output. So please just again repeat this what I just now said. For input A and B we will use W16 and V16, and for output we will use the LED which is configured to the port U16 in this constraint file. Now how to do that in this file? I have my W16 over here and V16 over here. I'll just click over here and this changes color. If you can see, this changes color. This becomes blue in color. So again I need V16 and W16, so this will change color. It tells us about the standards and all other things. So this is switch 1, switch 2. But now since in my program I used A and B, so instead of SW1 and SW2 over here at the endpoint, I will, instead of writing SW1, SW2, I will use A for one of them, and SW2 is replaced by B. So these two are the inputs. Now let's see what the LED is assigned to. LED is assigned to U16. So we have to find where U16 is. We'll go down over here. So U16 is in this LED side. So U16 is the first LED by chance. So we'll click on this. So now this LED is assigned to our output C. So we'll remove this. We'll keep only the curly brackets, and C is assigned to this. So we will save this. As of now, this is enough because this is a combinational design. So we don't need the information about clock and all. Otherwise, if we want the clock signal as well for our sequential design, so we'll have to uncomment the clock pin as well. And clock pin is the default pin, that is W5 pin. And we have to also uncomment this command which generates a clock of time period 10 nanoseconds. Okay, so this is for both sequential and combinational designs. Now when you're done with this, you have configured your board and we are ready to dump the code. But before that, we'll have to implement this design again. So we'll go for a run implementation again, and it will say it is out of date, so we'll have to click on yes again. Meanwhile, we will have to use a micro USB cable because that is what is supported by this FPGA board. I hope it is visible. So this micro USB cable is over here, and we have a port from this end. It is to be properly inserted over there. Once this cable is inserted, we can switch on our device. You see this is powered up, and you can hear the sound also on the system that it is powered up for further functioning and dumping. As soon as the code is implemented, we are ready to generate the bit stream and dump it to this particular design. So by chance, you can see that I have my two switches, the one which are over here, they are on, but there is no change in the LED that is marked as the output LED because we have not dumped the design. So even if I'm making some change over here, I'm making it off, the LED is still off. I'm switching them to on position, the LED is still off. So that means they are not assigned to anything. So let's keep them as off and let's see after we dump the code what happens. Now, once you generate the bit stream, the bit stream generation, we have to open the hardware. But before we go for open hardware, this cable is to be inserted and this should be active. So we'll go open hardware, we'll click on open hardware manager. We'll click on OK. So this hardware manager will actually ensure us that, remind me later, we don't want any surveys as of now. So let's go to the target board. So we have to over here click on open target, click on auto connect, it should connect it to it automatically. So we have to click on program device and this device is to be double clicked. It will automatically take us to the bit file that we have dumped in this program. So we'll just click on program. It says that it has not been created as of now because we are waiting for this to finish, so we'll have to wait for this to finish. This has been created, bitstream completed. So now we'll click on add program, yeah, sorry, program device, the device which is already selected. So and click on program, it has programmed the device. Now let's see, I'll again show what to do over here. Click on program device, this device is to be selected and it has generated this bit file. Now previously it showed an error, now we have to click on program and programming done. Now as you can see that we have nothing available at the output, and when one of the inputs is 1, no change occurs. Now when both the inputs are 1, the LED is glowing and this is the operation of the AND gate. If any of the inputs is say 0, it goes to off state. Both inputs are 0, it goes to off state. Now this is 1, nothing happens. Only this one is 1, second, nothing happens. Now when both are 1, then only this particular program is working as an AND gate. So this is how we can design an AND gate. Like this, we can design all other multiple gates, whichever you want to do. And we hope that we will do those design on the basis of request also. If you want some of the designs to be designed by me, you can drop them in the comments. I'll try to find some time and make them as well. Thank you.